All right, today we're going to be in the Unit 5 packet titled Exponents and Exponential Functions, and we're going to be on pages 10 and 11. So we're done with the exponent rules, so now we're going to start talking about exponential functions, which can be written as y equals a times b to the x power. So whenever you have a variable in your exponents, okay, that makes it an exponential function. All right, so if your b value, so whatever number sits with the exponent of x, is greater than 1, it's an exponential growth function. And that means that it's increasing. All right, if b is ever in between 0 and -1, okay, that's an exponential decay. So that means our graph is decreasing. All right, then another word that we are going to talk about is called an asymptote. And this is the line which the graph gets close to, but never touches or crosses. You're going to talk more about asymptotes in Algebra 2, so we're just going to kind of briefly talk about them, and I'm going to show you a simple way to find them using exponential functions. All right, so going down to the examples, number 1, we want to classify as an exponential growth or decay, create an XY table of values, and then graph, and then we're going to identify the key characteristics. So when you have an exponential function and you're graphing it, the first thing you're going to do is make an XY table. All right, your x values are always going to be -2, -1, 0, 1, and 2. Okay, that's always how you're going to set up your XY table for exponential functions. Now, to get our y values, okay, you're going to take these x values and you're going to plug them in for x in our function. So in your calculator, you're going to do 2 to the -2 power. And when you do that, it's going to give you 1/4, but we're graphing. So for me, I like to graph in decimals because I can kind of tell where the decimals are more than a fraction. So I want to turn that into decimals. So then I'm going to do 1 divided by 4, and it's going to give me 0.25. All right, then we're going to do -1. So I'm going to change that. So I'm going to do 2 to the -1st power, which gives me 1/2. Then I want to take that and put it as a decimal. So I'm going to do 1 divided by 2, which gives me 0.5. All right, for 0, okay, anything raised to the 0 power is always 1. Okay, we talked about that when we did exponent rules, so I'm just going to put a 1. Okay, if I do 2 to the 1st power in my calculator, that's 2. And then 2 to the 2nd power is 4. So now we can graph these points. So -2, 0.25. Okay, for the decimals, you're just really going to have to guess where they are. As long as your graph has a similar shape and looks the same as mine and how it should look, then I'm going to mark it right, okay? So -2, 0.25. So I'm going to go over -2 and go up just a little bit. All right, then -1, 0.5. I'm going to go a little bit higher than my previous point. 0, 1, 1, 2, and then 2, 4. So your graph should make kind of a curve. And we're just going to kind of roughly connect those dots. So that is what your graph should look like. All right, so now we're going to do the key characteristics. So growth or decay. So remember, my function was y equals 2 to the x power. Whatever number sits with x, that tells us if it's growth or decay. So if 2 is bigger than 1, it's growth. If it's in between 0 and 1, it's decay. So 2 is bigger than 1, so that means this is a growth function. All right, your domain is always going to be all real numbers. All right, and then range is our y value, so that's this line, okay? So I want to kind of think about where the graph turns, which it starts to turn right here, okay? And then it goes straight forever and ever and ever. And it's never going to cross this line right here. So what y value is that? That is y value of 0, okay? And then since it's a growth and it's going up, okay, it's not ever going to go below 0, that means y is greater than 0. All right, the y-intercept. So if you go to your table, you find where x is 0. This point right here is your y-intercept. So 0, 1. And then your asymptote is the same thing as your range. I'm just going to put an equal sign instead of the greater than sign. All right, and then that's how you graph an exponential function. So let's do number 2. So we have y equals 1 over 4 to the x power. So I'm going to start out by making my xy table. My x's are always going to be -2, -1, 0, 1, and 2. Then I'm going to plug in my x values in for x in the function. So I'm going to do parentheses 1 over 4 to the -2 power. And when I do that for -2, I get 16. Then you're going to do parentheses 1 over 4 to the -1 power. And that's going to give me 4. Anything raised to the 0 power is always 1. Then when I put a positive 1 in here, it's going to give me 1 over 4. So I want to turn that into a decimal. So I'm going to do 1 divided by 4, and that gives me 0.25. Then when I put a 2 in there, that gives me 1 over 16. So I do 1 divided by 16, and I get 0.0625. And now we're going to graph it. So the first point, -216, okay, we can't graph 16 on this graph because our graph's not that big. So we skip that point and we just go to the next one. So 1, -1, 4 goes right there. 0, 1. Then 1, 0.25. And then 2, 0.0625. So then my graph is going to look like this. So now we're going to find the key features. So if we look at our function, which was y equals 1 over 4x, all right, this number is with the x, so that number is less than, or it's in between 0 and 1, so that means this is a decay function. Our domain will always be all real numbers. All right, if we're looking at our range, which remember is our y values, our y's stay above in this section. Okay, they're never going to drop down here. So that is at a y value of 0. So that means y is greater than 0. All right, on my xy table, I need to find where x is 0. So my y-intercept is going to be 0, 1. And then the asymptote is the same thing as the range. We just change it to an equal sign. All right, let's look at number 3. So we have y equals 3x minus 1. So when we're graphing, I'm going to start out making my xy table, and I'm going to have -2, -1, 0, 1, and 2. All right, then we're going to go through and plug in our x values for the x function. So that's going to be, in my calculator, I'm going to do 3 to the -2 minus 1. All right, and that gives me gives me 8/9, but I want the decimal, so I do -8 divided by 9, which gives me -0.8. Then I'm going to do 3 to the -1 minus 1, which gives me -2/3, but I want the decimal, so I do -2 divided by 3. That gives me -0.6. Now I'm going to plug in 0, and that's going to give me 0. I'm going to plug in a 1. That's going to give me 2. And then I'm going to plug in a 2, and that gives me 8. All right, so now we're going to graph these. So -2, -0.8, -1, 0.6, 0, 0, 1, 2, and then 2, 8. 2, 3, 4, 5, 6, 7, 8. All right, so that's what your graph should look like. So now, going to the key features, we have y equals 3 to the x minus 1. So whatever number sits with x tells us if it's growth or decay. So our number is 3. It's bigger than 1, so that tells me that it's a growth. My domain is all real numbers. Then my range is my y values. Okay, if you look, our y values never go below this value right here, okay, which is -1. So its y is greater than -1. If I look back at my xy table, I got to look where x is 0. So it's 0, 0 for my y-intercept. And then my asymptote is the same thing. I just change it to an equal sign. All right, number 4. We have y equals 1/3 to the x power plus 4. So I'm going to start with my xy table. I'm going to do -2, -1, 0, 1, and 2. All right, I'm going to pause the video here, and I want you to go through and fill out the table on your own. All right, check your table with what I have. And now we're going to graph it. So our first point is -213. We are not able to graph that point because our graph doesn't go up to 13. It stops at 10. So we skip that point and we go to the next one. So -1, 7. So I go over 1, 1, 2, 3, 4, 5, 6, 7. All right, 0, 5. So I'm going to go up 5. Then 1 is at 4.3. and then 4.1. And so this is what your graph should look like. All right, so now for our key features. All right, so remember, to tell if it's growth or decay, we're looking at whatever number is sitting with x, and this is 1/3. So that is in between 0 and 1. It's not bigger than 1. So this is going to be a decay. My domain is always all real numbers. Okay, my range is my y values, and if you look, our graph never crosses this y value right here because it turns. So if I count up, that's 1, 2, 3, so that is at a positive 4. So y is going to be greater than 4. My y-intercept, if I look at my xy table where x is 0, it's 0, 5. And then my range is the same thing as my asymptote, I just change it to an equal sign. All right, let's look at number 5. So we have y equals 1/4 times 2 to the x power. So I start with my xy table. I do -2, -1, 0, 1, and 2. Then I want you to pause the video here and fill out the xy table and graph it on your own. All right, so this is what your table and your graph should look like. Now we're going to do the key features. So our function is y equals 1/4 times 2 to the x power. So whatever number sits with x tells us if it's growth or decay, and it's 2, which is bigger than 1, so that's a growth. Our domain is always all real numbers. Our range, okay, we're talking about our y values, and it never crosses this y value right here, which is at 0, so y is greater than 0. If I look over at my xy table where x is 0, I can find my y-intercept, which is 0, 0.25. And then my asymptote is the same thing as my range, just with an equal sign. All right, let's look at number 6. So we have y equals 5, parentheses, 1/2x minus 3. So I start with my xy table. We always put -2, -1, 0, 1, 2. All right, when I plug my values into my function, for -2, I get 17. For -1, I get 7. For 0, I get 2. For 1, I get -0.5. And then for 2, I get -1.75. So now I'm going to graph these. I'm unable to graph where x is -2 because our graph doesn't go up to 17, so we're unable to graph it. So I'm going to start with -1. So -1, 7. All right, then 0, 2, 1, -0.5, and then 2 is -1.75. So our graph goes like this. And then we're going to do the key features. All right, so to tell if it's growth or decay, we look at the number that's sitting with our exponent of x, which is 1/2. So since that is in between 0 and 1, that is decay. Our domain is always all real numbers. All right, for our range, that's our y-axis, okay? And if we look, it's never going to cross this x value right here, which is -2. So that's y is greater than -2. If I look over at my xy table for my asymptote, I get 0, 2, and then my y-intercept, and then my asymptote is y equals -2. And that concludes the notes for graphing exponential functions.